Hey there, teachers! Welcome to a quick field guide designed to give you a major heads up on the common hurdles your students are likely to face in earth science. We're going to break down some of the trickiest topics so you can get ahead of the confusion and really guide your students to that aha moment. So, before we jump into the nitty-gritty science, let's talk about why this is so important. Why is it so critical for our students to nail these concepts? Well, as it turns out, it's a huge part of what they're expected to master. Just look at this breakdown of the STAR test. Earth and space accounts for almost 40% of the total points. That is a massive slice of the pie, right? It makes getting these concepts right absolutely essential for your students' success. So, where's the disconnect? Here's the thing. The biggest challenge isn't just getting students to learn new facts. It's getting them to unlearn old ideas. They walk into our classrooms with all these pre-existing beliefs they've picked up from movies, cartoons, you name it. And that's where we come in. Our job is basically to be mythbusters. So let's get ahead of the game. We're going to pinpoint the most common misconceptions your students have so you can tackle them head on from day one. All right, first up, sedimentary rocks. It's a fundamental topic, but there's a really common oversimplification that leads to a myth that is practically baked into their brains. Okay, here's a classic one. If a rock doesn't have stripes, it can't be sedimentary. But that's not the case at all. The real defining feature isn't the pattern, it's what it's made of. It's got to be made of little pieces of other things, sediments that are all cemented together. Some look like a layered cake, for sure, but others, like shale, can look pretty plain. And here's another hurdle. Students often picture it like just squishing a mud ball in your hand until it gets hard. But it's way more complicated than that. It's actually a two-step process that requires some serious heat and pressure deep underground. It's a real 1-2 punch. First, you got compaction. That's the intense squeezing from the weight of all the layers piling on top. Then comes cementation. This is like a natural glue, where minerals seep in and fill up all the little spaces, locking everything together into a solid rock. So remember, it's all about squeezing and gluing. Okay, let's keep going. Next up, we're diving into a topic that is just ripe with misconceptions: fossil fuels. And get ready, because this is where the whole dinosaur myth really reigns supreme. This is the big one. Most students, and let's be honest, a lot of adults too, think oil comes from dinosaurs. It's an idea we see everywhere in pop culture. But the science tells a totally different story. The real source isn't some giant T-Rex, but trillions and trillions of tiny microscopic organisms from ancient oceans. And in fact, the famous Paige-Keeley science probe on this exact topic shows just how all over the place student ideas are. You see everything from ancient plants, which is kind of getting warm, to the idea that oil is just this black liquid that's always been there. But only one of these students is on the right track. And the prize goes to Mia. You see, the key ingredients are microscopic life in an ancient ocean, buried under tons of sediment, and then cooked by heat and pressure for millions of years. No dinosaurs required. And it's a similar story for coal. We've got to correct that dinosaur idea again, but the setting is completely different. We're not in the ocean anymore. For coal, you have to take your students back in time to these vast, ancient, swampy forests. And the process itself is pretty cool. It's all about dead plants in a swampy, low-oxygen environment that get buried by mud and water so fast that they can't completely rot away. Instead, they just get cooked under all that pressure for eons, slowly changing into the coal we use today. All right, finally, let's talk about the water cycle. Now, this is something your students have probably seen diagrams of a million times, but they often see all the different parts without ever really understanding the power source that drives the whole system. So when you show them a scene like this, they have a lot of different ideas about what makes it all go. They see the moving parts, the rain falling, the rivers flowing, the ocean churning, and it kind of makes sense to think the energy must be coming from one of them. So they'll point to things like waves or moving clouds. But the true engine, the actual powerhouse for the entire water cycle, is 93 million miles away. It's the sun. The sun's energy is what kicks the whole thing off by turning liquid water into vapor. And this right here, this is the crucial partnership. The sun provides the energy, and the ocean provides most of the water. This simple interaction is the absolute starting point for everything else. Without the sun's heat, that water would just sit there. Now, here's another subtle but super important point: how clouds actually form. Students often think of clouds as just being visible steam, kind of like from a tea kettle, but it's actually a true phase change. That invisible gas, the water vapor, has to get cold enough to condense back into billions of tiny liquid water droplets. That's what a cloud really is. Okay, so let's do a quick rapid-fire recap of our myth-busting to get you all set for your lesson planning. These are the big ideas you'll want to have in your back pocket. First, for sedimentary rocks, tell your students to look for cemented sediments, not just for stripes or layers. That is the real key. Next, when it comes to fossil fuels, just remember, tiny ocean critters for oil, giant swamp plants for coal. It's officially time to ditch the dinosaurs. And finally, for the water cycle, have them look up to the sky. The sun is the one and only engine that gets that whole process started. You see, just by knowing where your students are likely to get stuck, you're already a huge step ahead. You can design lessons that tackle these ideas directly. Now you're all set to guide them from myth to matter, and from confusion to some real, lasting understanding.